Why hello, lovely humans! I'm Jen Foxbot, and I am so glad that you're here to hang out with me while we explore how to make circuits using some things that you can find around your house. So, the first thing that you will need is a source of electricity. And for that, I'm going to be using one AA battery, which looks like a cylinder. I'm also going to be using a motor. Ooh, motors, so fun. And you can find these in any of your toys that move. And if you don't have any toys that you want to take apart, definitely ask your parents before you do that. Then you can go to a thrift store or find a friend that has something that's broken and you can take it apart together. When you're doing this, definitely make sure that you have an adult to help you with some of the tools because it can be kind of tricky. And you want to look for something that is shaped just like this. Here's a little secret about where I got mine. I actually got mine from an electric toothbrush. So that's one of my favorite things to do, is to think about fun ways that I can harvest or snag parts from other things. And electric toothbrushes have the perfect motor that I love to use for this really fun project. Okay, so once you have a battery or a source of electricity, and you have a motor which will use the energy from the battery, you'll also need something to transfer the energy from the battery to the motor. And to do that, our material needs to be what's called conductive. Conductive. And it's okay if that's a confusing and big word. It was confusing to me at first too. Conductive materials are really good at transporting electricity. What are some types of conductive materials? What sorts of things do we see when we take apart electronics? What colors are they? What shapes are they? What is it made out of? What do you think? Yeah, we tend to find long, thin things that are made out of metal. So there are lots of different things that we can find around our house. If you don't have wires like these, you can also use metal paper clips, and you can unbend them to make it a little bit easier and more like your standard wire. Sometimes I like to leave one part bent because you can hook it around the battery just like that. Oh no, my finger's in the way. Let me try to show you better. Just like that. You can also use aluminum foil because it's made out of metal and it conducts electricity too. And here's a super fun discovery that one of my students made. You can use pipe cleaners. So if you pull off some of the fuzz on your pipe cleaner, you'll get some metal underneath. And that metal will conduct or transfer electricity. So we can build circuits with the pipe cleaners. Yay! Once you have your source of electricity, the thing that is going to use the electricity, and something that will transfer or move the electricity from the battery to our motor and back to the battery, we are ready to build our circuit. So I sort of hinted at how we build our circuit when I said we need something to take the energy from the battery, that's where it lives, that's where it's made, into the motor, and there the electricity will lose some of its energy. It's kind of like when we go to school. We wake up and have some energy, or maybe a little bit tired, but once we get woken up, we have some energy. And then we go to school and we use our brains and our bodies to do some cool things and learn some stuff. And by the time we go home, we're pretty tired. We've lost a lot of our energy. And so the electricity, it loses its energy when it uses it to move the motor. And once it's lost its energy, it has to get back home too. Oh no, it can't live in the motor. The electricity would be very sad if it lived in the motor and it wouldn't do any work at all. So we have to give it a path to go to the motor and a path to go back out of the motor and home to the battery. But unlike you and I, we typically leave our house and come back through the same door. Electricity leaves its house, or the battery, through the front door, the positive side. And if you're like, where is the positive side? When you look on your battery, you want to look for a little plus sign. So the electricity leaves the front door of our battery, the plus side. It goes into our motor, and then it comes back out the motor and into the negative side of the battery, or the back door of the battery. So now that we know that, how do we use this new knowledge to build a circuit? Once you have all of your materials, I want you to try and explore a few different things to turn the motor on. And you'll know when the motor turns on. So I want to give you a few minutes to play around on your own. I encourage you to pause the video until you figured it out, because that's the best part of this, is when you discover it on your own. So go ahead and do that, and I'll sit here quietly. You got this. Did you get it yet? If not, keep trying. Okay, so if you still haven't figured it out, if you haven't gotten the motor to turn on, that's okay. You can either keep trying, which is awesome, or if you're feeling a little bit frustrated and you want some help, you can watch while I show you how to do it. So first, I like to put my wires in the motor and get them to stay down. So if your wires are popping out, you can use some tape. And then I put the battery on top of one wire so that it's touching the metal of the flat part of the battery. And then I take the other wire and I touch the other metal of the battery. Whoa! A jittery motor! And that's it. Now you have a circuit. I have a challenge for you. What happens if you flip the wires? What happens if you set the motor down on the other wire and use the other wire to touch the top of the battery? Look at the motor and see what happens, and see if you can figure out anything different. I'll leave that for you to discover. So if you want to use something different, like pipe cleaners, let's try that out. So just like we did with the wires, I'm going to put my pipe cleaner in these little holes of the motor. I'm going to pull off some of the fuzz on the other side. And then I'm going to do the same thing with my other pipe cleaner. Why do you think I'm using two different color pipe cleaners and two different color wires? That's an interesting guess. I like it when we're creative and when we use our brains to think about things. So I'm using 2 different colors because it helps me keep the paths of my electricity separate. So, like I said, the electricity leaves its front door to go do work, or to go to school, I guess, and it comes back a different path when it's lost its energy. And so we need to keep those 2 paths separate because it makes our lives easier. Tee! Oh no, it came out. That's okay. If I spend a little more time or taped it down, it would work. So let's do that. And it's okay if this is taking you longer than it's taking me. I have done this a lot of times. And so the more times that you practice making circuits, the easier it gets. Just like with anything. Okay. Now I have my fuzzy circuit. Yay! Okay, so now what do? Well, it's up to you. You get to decide what you do with this fun, jittery little motor. But I'll show you one way that I like to make things move. So you can use tape or glue. Right now I feel in the mood for Play-Doh, so I'm going to use some Play-Doh to hold my motor down. And I'm going to stick it on this toy that I have that has wheels. And hopefully I can tape it down so that it stays connected. Okay, there's one side. Oh no, I'm gonna stick the battery in the Play-Doh too. Uh-oh, that didn't work. Oh, that's why. Because my motor wasn't able to rotate. Okay, so the Play-Doh doesn't seem to hold it down very well, but that's okay. It's very silly. Okay, I'm gonna try this. Maybe this way will work. Oh, nope. I wonder what else I could try. What do you think I should do? More Play-Doh? Okay. More Play-Doh. Hey, look at that. That worked for a little bit. Okay. Now that it works, I'm going to tape down the second wire, and hopefully this will hold it. Okay, let's see if I can do this. I want you to try and do the same thing, maybe with a different bottom for your motor. Okay, so it has a hard time moving, but that's okay. Maybe if I move it a little bit. Oh, that's very silly. Let's try on the counter. Nope, not quite. I think it's a little bit heavy. And it's a little bit lopsided. Look at that. Ha! That's funny. Okay, so I guess if I gave it a little push, it might help. Whoa! Where did it go? Whoa! Oh, there we go. Okay. So it looked like my motor, I'm going to undo this because that's kind of loud. So it wasn't moving very much until I squished the Play-Doh down more and made the motor stick to this little wheelie mabob thing. So I think tape might work a little bit better because the tape will hold it really well to this base. So what other sorts of things can you attach this jittery motor to make them move around? And I wonder if maybe you could design your own little wiggly wobbly robot that can move around using the motion of the motor. There are all sorts of things lying around your house that you can try. I wonder what you can come up with. If you build something that you're really proud of, I would love to see it. So please share it and tag me at JenFoxbot so that I can share in the joy of your creations. All right, so I would like you to go forth and explore the different ways that you can make things move using these types of jittery motors. If you end up with a motor that does not have a jittery bit on the end, also known as a counterweight, or something to make the motor shake instead of spin, you can add a piece of glue that's offset a little bit. And so the piece of glue will spin and the motor will shake. Hot glue works really well for that. You can also use some tape if you don't have hot glue sticks. All right. If you have any questions about this, I would love to hear them. And if you have any other ideas, please, please, please share them. I love hearing your wonderful ideas. One of the things I love about making is how creative we get to be and how we get to use random and silly things from around our house to make cool stuff. So go forth and play around and have a lot of fun. And I'll see you next time. Bye!